spent the first 16 years of my life over there, and I personally faced these problems. Like we've discussed over the past 20 minutes, all these problems are interconnected, and the solutions that solve them should be as well. Growing up, we had to drink water from wells because our natural water sources were polluted. We saw people die, have terrible quality of lives, die at young ages due to air pollution. WHO reported that, the UN reported that as well. And the one that, we see and interact with is lack of access to energy. Not just clean energy, just energy as a whole. We would go days, weeks, months, sometimes years without power. And these are things that we had to live through, that I had to live through with my family. And my co-founder, Richard, who's from Kenya, faced, a worse fate. He lost his mother and his sister to waterborne diseases.
Hello, David. Thanks for joining in Scouted by Gravy. I'm very excited to have you here. I came across Airbuild just a few days ago, and really what caught my attention is the unique solution you have come up with to not only capture carbon, but also purify water, and, just a holistic solution to solve multiple problems at once. But without spoiling it for our audience, I'd like to ask you to give us a background on, what basically Airbuild is doing and what kind of impact you are planning to make.
Of course. Thank you very much, Shabazz. I do appreciate the opportunity to share our story. So Airbuild at its core is transforming waste from water, rivers, our air, and our cities into value. So we build self-powered systems that utilize microalgae for carbon capture and water treatment. So we deploy these solutions close to polluted beds of waters, rivers, lakes, municipal evaporation lagoons. We take water from that polluted bed, send it into our system. Algae eats and feeds on nitrogen, phosphates, aggressively outcompetes other bacterial contaminants like E. coli. And at that point, the algae is growing. It's also photosynthetic like plants. So it breathes in carbon and releases oxygen. So that's the carbon capture part of it. So post this algal water treatment, we send the water down to our UV system where we dose it with UV to make sure that we are getting rid of 100% of the bacteria in that system. We then send that treated water back down to the river. We take the waste of that process, which is the algae biomass, and we combine that with local organic waste from the cities, be it biosolids, be it agricultural waste, animal waste, invasive species like trees. And we pyrolyze all that waste to create biochar, which is great for permanent carbon storage, as well as biofertilizer for the local farmers.
That sounds like a lot of innovative solutions working together. And what I can see is that all the byproducts as well are also helping you make the entire system sustainable. And basically, it's just like complete zero waste process, which is very interesting to know. So, David, I think my initial curiosity about the whole system was, and which is like, again, it's a question that is being asked to all the carbon capture startups these days. So, that is like, what is the efficiency and basically what are the impact numbers that you're able to hit? Because the current perception about carbon capture is a little bit turning towards a little bit negative, because companies are kind of exploiting this, that they just buy the carbon credits from startups and then they don't really improve the process. So just going towards that perception, is there any testing numbers you'd like to share, or what kind of impact you have seen this when the system works?
Of course. So algae in itself is 99% efficient in terms of capturing carbon. It's, we can't question nature, and our studies and our own prototype experiment shows us that algae will take organic and inorganic carbon. The question then comes into our storage process, because that's where, the industry as a whole has struggled. We are utilizing pretty much the oldest solution that we've had, which has been going on for thousands of years, which is turning it into biochar. And we're doing this because, for one, it is proven. And two, that waste is turned into something that is immensely valuable. There are companies that are using biochar for fascinating things, going from Hive Geo in UAE that are trying to regreen the desert. So they're pouring their biochar in the desert so that they can secure food source for their community, to companies like Solid Carbon that are using it to decarbonize bioconcrete and biocement. So that part of it is proven, and that's what Airbuild wanted to do. We wanted to tie in this new solution that we have to already existing solutions for provability.
Makes sense. So do you have you faced any integration challenges so far? Because I guess that's the like very obvious next question, that okay, this system works and it uses lots of technologies, lots of different technology in combination. But for example, basically what I understood after reading about you is that local water processing treatment plants, municipal corporation are kind of your target audiences, initial target audience, I would say. So have I got that right? Are those people you're going after?
So we're targeting small cities. We're targeting rivers. So our initial market is split. You know, if you even if you live in a big city and you have a polluted river or a polluted lake. I live in Vancouver, Washington, and last week alone I got like 6 different alerts saying, "Hey, do not go into that lake. There's toxic algae bloom." Which means I could be my own customer in terms of my city. And then we're also targeting small cities that do not have a wastewater treatment plant. They just have evaporation lagoons, which is a huge number of small cities here in the United States and also globally. You know, they can't afford to have a 40 to $80 million water treatment plant. So they run the water through primary and secondary treatment and then put it in these evaporation lagoons and hope to God that it evaporates before the winter comes, because winter comes, slow evaporation, and now their lagoons are full. The question is, what do they do? Build another lagoon or, you know, cough up cash on this expensive water treatment plant? So our solution is in between for them. It's low cost, it's proven, and it solves that problem of alleviating that load.
Okay, I guess it sounds really, it makes it sounds too good to be true. That's how impressive it is, because I've talked to a lot of carbon capture startups, and I've read about DAC systems as well and direct ocean capture as well. So what I see is that you're taking care of all the parts, right? All the waste that is being generated from purifying the water, as well as where the captured carbon is going to be. So really, I see how you're hitting all the marks. Now you mentioned about cost as well, and that is also something I'm also interested, that of course these kind of system are complicated to implement, and they are really not, they also have like specific geographical preferences where they can be implemented. So can you tell me a little bit about that as well? Like, is what kind of challenges did you face when it comes to, convincing, I would say, your target audience that this is more cost effective and this can be implemented easily and you won't face any integration issues maybe in your existing systems? So did you face any kind of those challenges, and how did you address them?
Yes, we definitely did. I mean, every industry faces, every company faces, you know, those challenges because, you know, the one thing they tell you is you are competing against the status quo. Forget about all your other competitors out there. You're competing against what they're doing right now, which is literally do nothing. So we ran into that problem as well, and we had to prove it out. And we prove it out using existing solutions, as we always do. Everybody knows about greenhouses. You can put a greenhouse anywhere. As far as you thermoregulate it, it will keep going. And you can grow plants in there. And that's really what we had to tell them. We're like, our solution is an enclosed algae pond, making that pond its own greenhouse. And for the integration, we've made it seamless. All we do is run a water transfer line into your lagoon, and we just pump that water into our system. That's all we need from you. Everything else, we integrate ourselves in terms of getting a harvester that's going to dewater the algae, in terms of having a line that's going to have the UV system, in terms of having a dryer and a steamer that's going to dry the biomass before pyrolysis. Those are things that fragmented industries already do. Every biochar company already has a steamer that's attached to their product. Every algae company has to harvest. So all we are doing is just pulling all these things and tying them together, which again has been a pain in terms of automation, but it's a pain that I'm very confident that my team can solve. We've made some strides. We haven't gotten to the point where we are integrating everything together yet, but I'm very confident that we can do it.
That's great. So what is currently going on? What's the like immediate next challenge that your team is working on solving?
So right now we are deploying our solution in Green River, Utah. We're building our demo. We broke ground on the 12th of last month. We have completed our excavation. We are currently deploying our peripherals and all the internal components. We plan to have that up and running in about 6 to 8 weeks. And the goal of that is to take water from that river, and the Green River flows to the Colorado River, and a bunch of states, California, Arizona, Nevada, here in the US, rely on that water. And that water is polluted with E. coli. to the point where they have sensors deployed at different stages to tell the constituents when it when it is or when it isn't aggressively polluted, to the point that they shouldn't even near that water because you can get sick and die. So our goal is to take water from that river, treat that water, because the algae strain that we've chosen, Chlorella vulgaris, outcompetes E. coli on a daily basis. So all we're doing is creating the environment for chlorella to grow and pumping the water in. Chlorella is going to do its thing, harvest, and send the water back to the river. That's what we're trying to prove right now. We've done this on a small scale with our prototype at University of Massachusetts. And now we're just moving, which was a 52-gallon panel. Now we're moving to a 54,000-gallon pod to prove it out on a larger scale, and hope that by next summer, we'll be integrating on 2.5 acres of land, which is going to be multiple pods. And that's when the true automation challenge comes in.
Yeah, I get my following question is going to be about that what challenges do you see when you scale the system? So a lot of things changes and a lot of new technology might need introduction. So do you foresee any hiccup, I would say, that you are like prepared for that? Okay, when you scale the system, this is what we need to solve for.
Yes, we are. We
Hmm.
are ready for a bunch of problems. I mean, for one, we're dealing with, biology. You're trying to control biology and nature. I mean, theoretically speaking, the algae was going to grow and bloom in the water anyway. All we're doing is making a bypass, right? And cultivating that algae ourselves. So it outcompetes the algae that's out there for the nutrients. But keeping biological materials, history has shown us that keeping biological organisms alive is hard, or in that stable environment, and hence the innovation of greenhouses. So there's some things that we foresee. There's some things that we're like, okay, if this thermal regulation doesn't work, how our Pettier plate's going to kick on, how our sensors going to integrate, how our sensors not going to corrode, because again, we can't just dunk the sensors in the algae. That's going to clog the orifice. So those are questions that we're asking ourselves. How's the maintenance for the system going to go? And I'm very glad for my team, Dr. Richard Marita, John Booker, Dr. Ejike Kenopurum, who have brought their amazing heads together to devise some innovative ways to maintain and keep the system operating in a continuous system, which is our vision.
Okay, so do you also see any inefficiencies in the system? I mean, of course, since we're talking about algae and there's a wastewater stream which sometimes it is a different level of polluted and sometimes it has different kind of nutrition. So how do you manage that so that the output is a little steady, or at least basically your system keeps on running consistently on? Yeah.
So we manage those through bypasses as well as sensors. So like you said, the water wastewater is never constant. Also, water from a river is never constant. My co-founder Richard says this best. He says you can never take 2 cups from the same river and expect them to be the same. So it's one thing where we have sensors that are deployed at the inlet. So we track the parameters that we need: nitrogen content, dissolved CO2, TDS, and a bunch of other metrics that we need, temperature. And once the water is in our system, because our system is literally holding it for about 8 to 15 days during that algal cultivation, we track it there as well. And at the outlet, we track it again. And if our sensors notices, and that's where the automation comes in, and I'm very fascinated about this stuff, where once it notices that the consistency is not the same, a few things are off, it sends it through a valve controller that reroutes it back to the system, because we need to make sure that we're getting rid of the nutrients, that we're getting rid of the heavy metals, that we're getting rid of the bacterial contaminants, so that the water that we're sending back to the river is always constant, even though the one that's coming in is not. At the same time, the sensors that we have deployed in the system let us know when to harvest. So we don't harvest up until the pH is between our set parameters. Otherwise, it stays in and the algae just keeps on growing.
Makes sense. I think multi-level check, I can see how it can ensure the long-term stability of the system.
Yes.
My next curiosity is mostly about the energy usage and how energy efficient this entire system is. And simply because this is again a very obvious FAQ about carbon capture systems, that they
Yes.
cost more energy than they save. So just want your thoughts about that basically. If you, I'm sure you must have some numbers to share.
Yes. So we looked at that, and that's why we tag ourselves self-powered. We do not plug into the grid. We do not utilize energy from the grid. We generate 100% of the energy that we use on site. And being a biomechanical solution, we utilize way less energy in our process. And that's something that I was blown away about. We utilize roughly 200 to 800 kilowatt hours per ton of CO2 that we capture, compared to the direct air capture market that's between 2,000 to 5,000 kilowatt hours. And our system, like I said, is enclosed. But it's not just enclosed with polycarbonate, it's enclosed with solar panels. And we're mimicking photovoltaics, which is something that I was talking to someone yesterday from CSI, and they were like, I am shocked that this is not something that's more well known. So photovoltaics is the concept of deploying solar panels on top beds of water, because 85% of the energy from traditional solar is lost due to heat. But if you deploy the solar panels on top of a bed of water, the sun goes down, evaporation goes up, cools those solar cells, boosting the energy generation ability by roughly 12.5%. So that's literally what we're doing. We're digging holes in the ground, finding them, putting our pod, and covering with solar panels. So when the evaporation eventually goes up, it's cooling those panels and we're generating more energy. So we generate more energy theoretically than we would need. At full deployment, we anticipate having 25% extra energy. And for that, we've signed an MOU with a company called Hiwatt that does hydrogen-based energy storage. And we plan to have that energy stored on site. There are innovative things we can do with it. We can work with the cities to interconnect that to the grid to send energy back to the cities. We could also have that charger and, deploy that as an EV charger for the local constituents when they need to charge their cars. So there's so many innovative things we can do with our excess energy. And that's, something that we are the only ones on the market that can boast of.
You make it sound very exciting, and I'm really, it's just like all the things are being checked. So I really like how you have like already planned everything and how everything is coming together here.
Yeah.
So David, I think I have just a last few question, and that is one is about regulation and policy, because I see a lot of startups, they face this challenge that they have to adhere to local regulations of wastewater treatment and usage of river water. So what were those? Did your team also face such regulatory challenges that that you had to navigate and get approvals on? So yeah, but just on
Yes.
those.
Yes, we did. We faced those challenges as with everyone who's trying to pull water from a river or put water back into the river. But for us, we got through our permitting in about 3-4 months. My co-founder, John Booker, ran that process diligently with help from everyone in the state of Utah. Water permits, water rights, Department of Water Safety. He was in calls damn near every day. And we sped through that process mostly because we do not consume the water. What we are doing is treating the water and sending it back. So we leave the water better than we found it. So we're able to speed through our process. The one permit that we're still waiting for right now is our discharge permit, but we anticipate that coming hopefully within the next few months, and we will be fully permitted. For our other deployments that we're currently in conversations with through our letters of intent, the city, since we're working with the city's water treatment plant, they work with us to get the permits, making, that political bureaucracy a whole lot easier.
Okay, David, I think that answers my question, all of my questions actually. Just one, my personal curiosity, and that I try to learn from each all the founders I talk to, is that since this is a high competing area, even though your solution is very unique, but there are this problem is being solved by a lot of companies in their own different ways. Some are very efficient, some are not. But the bottom line is like it's a highly competitive area, and the solution that you have is obviously very unique, but it's also very simple as well. If anybody figures this out and they are able to do it efficiently, they should everybody should be doing it. So what I want to ask you is that, and like any founder, you must have also faced this must have also made your nights sleepless, that maybe what if this doesn't work, and what if you guys run into a scaling problem, maybe a regulation problem, or that the founder fear. I'm sure you must have had that. But basically, what keeps you going here, and basically what's the true motivation behind building this and scaling this?
It comes from, the true motivation comes from our own personal experiences. So I was born in Nigeria. I spent the first 16 years of my life over there, and I personally faced these problems. Like we've discussed over the past 20 minutes, all these problems are interconnected, and the solutions to solve them should be as well. Growing up, we had to drink water from wells because our natural water sources were polluted. We saw people die, have terrible quality of lives, die at young ages due to air pollution. WHO reported that, the UN reported that as well. And the one that, we see and interact with is lack of access to energy, not just clean energy, just energy as a whole. We would go days, weeks, months, sometimes years without power. And these are things that we had to live through, that I had to live through with my family. And my co-founder, Richard, who's from Kenya, faced, a worse fate. He lost his mother and his sister to waterborne diseases. So he has dedicated his life through his non-profit organizations as well as Airbuild to making sure that people in those situations do not face a similar fate. And the team, everyone on the team has a story that relates to this. And that is what keeps us going. The fact that we know that we cannot fail. We have to do this not only to heal our own trauma and experiences, but to make sure that people in those situations do not face the same misery that we did. That is our motivator, and that's what keeps us going.
That was all the questions I had, and really, not only I got to know a lot about how Airbuild is doing things and how this carbon capture system works. I really enjoyed my conversation with you as well, especially knowing your story and from where you're coming from and how you have solved all these problems. Really, I appreciate your time with this.
Well, thank you very much, Shabazz. I really do appreciate the opportunity. It's always amazing when we get to take a day from the lab, jump on and, share our story. I think what we're building is very interesting, although I'm very biased, but it's amazing to share more about it, especially as we see this vision, get realized on site.